This video is about solving simple radical equations. Let's get started. Radical equations are equations with radicals in them. Specifically, some algebraic expression with the variable inside the radical. And we're working in this, how do you solve an equation like that? So we'll start with some very simple equations and then work to some more challenging ones. Okay, the first thing that we'll do here is we'll get the radical by itself. In number 1, we added 6 to both sides. Okay, and then the next thing we do is to get rid of the radical, and that's by squaring both sides. Okay, now one thing that wasn't done here is that you should always check to see if your equation is still true in the original equation. And we do that because we may get what are called extraneous solutions. Okay, solutions that are created by squaring both sides that don't actually work in the original equation. Okay, and we'll see an example of that in a little bit here, but not in this one. Okay, so if I check, I plug the 100 back into the original equation and get this. So this one's just fine, okay? And so I know that 100 is the solution to this radical equation. Next, let's look at number 3. I will again get the radical by itself by subtracting 6 from both sides. And I get the square root of x is equal to -2. And then we'll square both sides. And I get x equals 4. Okay? But I have to check to see if that still works in the original equation. And it does not work in the original equation. Okay, and what happened is that as we squared both sides, we got a situation where 2 and -2 squared are both 4. Okay, and that can happen as you square both sides. So this is not a solution. This is an extraneous solution. Okay, extraneous meaning extra, but not like the good extra, but like the I don't really need this kind of extra. So the process that we just used to get the radical by itself, to square both sides, and then to solve the equation and check for extraneous solutions, that same process is the process that we use for more challenging radical equations. Let's look at some of those. So again, the process, to write down very clear what the process is, we will first get the radical by itself. Or in some cases for us, if there's 2 radicals, then we'll get 1 radical on each side. Okay, we'll then square both sides. And we'll always check the solutions. Okay, so let's do numbers 1 and 2 here and see and follow these steps. So in number 1, I'm going to get the radical by itself. Okay, and I will first do that by adding 4 to both sides, and I get 2 root 3x plus 5 is equal to 2. Now at this point I have 2 options. I can divide both sides by 2, and that's what I'll do here, because I don't get any really nasty fractions. Okay, if I would have gotten nasty fractions by dividing this way, the other option you have is by squaring both sides like this, and you would get 4 times 3x plus 5 is equal to 4, and then I can solve it that way. But if you can divide it and avoid some nasty fractions, then that is the easier way. So I'm going to divide by 2 and divide by 2, and I get the square root of 3x plus 5 is equal to 1. Okay, so I've done it. I've gotten the radical by itself. Now I'm going to square both sides. Okay, and the square and the square root cancel each other out, and I have 3x plus 5 is equal to 1. Okay, and now I solve the equation. Square both sides and solve, I should have said. Okay, so now we'll solve this equation. I'm going to subtract 5 from both sides to get the x by itself. I have 3x is equal to negative 4, and I will divide by 3 and divide by 3, and x equals negative 4/3. Okay, now before I box this and celebrate that I have the answer, I'm going to check to see if this actually works in the original equation. Right here is a point that a lot of students are not comfortable with, and that's multiplying fractions. Okay, you can put this 3 over 1, and I could multiply top and bottom, but just keep this as simple as possible. I will cross cancel, which you can do when multiplying. Okay, and then multiplying the tops together and get negative 4 over the bottoms together. 1 times 1 is 1, and so I get negative 4. Okay, and this one works, okay? But I don't know that until I finish checking my answer. Once I got it checks, I will then box this answer and say, yep, the solution to this equation is negative 4/3. Okay, let's also look at number 2. So I start by getting the radical by itself, which it already is. That's really convenient. And so I'll start on the second step by squaring both sides. Okay, so the next step in solving for x, this is now a quadratic equation where I have x squared and x terms, and so I'm going to get one side equal to 0, and I like my leading coefficient to be positive, so I'm going to move the 2x and the plus 15 to the right side of the equation by subtracting 2x from both sides, like terms, and subtracting 15 from both sides, and I get 0 is equal to x squared plus 10x plus 21. Okay, now if I can factor, I will factor. Okay, and this one actually does factor, and I get 0 is equal to x plus 7 and x plus 3, which means that using the zero product property, x is equal to negative 7 and x is equal to negative 3. Okay, now before I celebrate, I'm going to check my solutions. And so I have room to do that. I'm actually going to erase this stuff over here so that I have some more space to check my answers. Okay, so checking negative 7. So I got 1 is equal to negative 1, which is not true, which means this negative 7 is an extraneous solution. Okay, so again, notice that I get 1 is equal to negative 1, and when both of those are squared, you get a true statement. 1 is equal to 1. Okay, and so that's kind of what happens is there's extra solutions that you get as you square both sides, but you do still also get the true solutions. So you have to square both sides, but check to make sure you don't have any of those other extra ones in your solution. Now let's check x equals negative 3. And this one does work. So I get 3 is equal to 3. That's a true statement. And so this is a solution. It's the solution to this equation. Okay, there's one last idea that I want to bring up before we end this video. Okay, and that's up here, number 5. Without solving the radical equation, the square root of x plus 5 plus 9 equals 0, how could you tell that this has no real solutions? Okay, well, let me show you. The first step we would do is to get the radical by itself by subtracting 9 from both sides. And I get the square root of x plus 5 is equal to negative 9. Now, notice that I have a square root equals a negative. Okay? Now, we know that I can take the square root of a negative number and get complex solutions. But if you have the square root of x, that will never be equal to a negative number. Okay, the square roots of x, the square roots will always be positive numbers or 0, never negative. So keep an eye on situations like this where a square root, in this case square root of x plus 5, is equal to a negative. If you see that, you can just stop there and say no solution. Okay, because a square root will never be negative. If we did go through and solve this equation and found whatever the solutions would be and plug them back then, every solution would be extraneous. So it's not terrible if you don't recognize this because you just get everything is extraneous, but it would help you out a lot if you recognize saying, oh, a square root can't be negative, there's no solution, and you stop right there. All right, this video was about solving simple radical equations. Thank you for watching.